4.5 billion years ago, our universe was nothing like what we see today. It was a time before planets, before moons, and even before the stars themselves had lit up the heavens. Imagine a universe devoid of light, a vast, infinite expanse where silence reigned supreme, and darkness stretched on endlessly, unbroken by even a flicker of starlight. In this primeval void, there were no worlds to orbit the distant suns. No suns to shine. No galaxies swirling with the brilliant energy of life. What existed was a cold, desolate emptiness, a cosmic wilderness that stretched beyond comprehension. It was a place where time seemed to stand still, where nothing had yet taken form. No mountains, no oceans, no atmosphere to breathe or life to experience it. The universe in this era was a place of utter stillness, like a canvas waiting for the first stroke of creation. But this quiet emptiness was far from peaceful. Unseen, in the depths of this cosmic abyss, forces beyond human imagination were already stirring. Gravitational waves rippled through the void, colliding with ancient clouds of gas and dust left behind by stars that had lived and died long before the birth of our solar system. These remnants, scattered across the vastness of space, were all that remained of the fiery giants that once dominated the skies. Now, nothing more than dust, cold and seemingly insignificant. And yet, within these specks of stardust, the seeds of something miraculous were hidden. From this quiet chaos, from the remnants of long-dead stars, something extraordinary was about to happen. Matter, seemingly at random, began to drift together, drawn by an invisible force, a gravitational pull that slowly but surely gathered particles of gas and dust into dense clouds. These clouds, still invisible in the darkness, held the potential for something much greater than the silence and void that had ruled for eons. Slowly, almost imperceptibly, these clouds began to condense, spiraling inward, pulled by the weight of their own gravity. In the heart of one of these clouds, deep within what would one day become our solar system, something astonishing was taking place. In a process that would last millions of years, the cloud began to collapse in on itself, its core becoming denser and hotter with every passing moment. The weight of countless tons of stardust pressing inward, squeezing tighter and tighter until the very atoms themselves began to fuse. And then, for the first time, light. A star was born, a fierce, blazing ball of fire and energy. This was the birth of our sun, a luminous beacon that would become the heart of the solar system, a force of gravity so powerful that it would hold entire planets in its grasp. It was a moment of cosmic creation, a transformation from darkness to light, from chaos to order. But this was only the beginning. Around the newborn sun, the same forces of gravity that had brought it into existence began to work on the leftover debris, the dust and gas that hadn't been drawn into the star. These fragments of matter began to collide, sticking together, growing larger with each impact. At first, they were tiny, mere grains of dust floating in the vast emptiness of space. But over time, these grains became rocks, and those rocks became boulders, and soon entire worlds were forming. This was the chaotic and violent birth of the planets, including our own. Earth did not simply come into being in a moment of quiet creation. It was forged in the fires of cosmic collisions, built piece by piece through a series of violent impacts, where molten rock fused together, creating the very foundation of the world we now stand upon. But the story of Earth, of our home, goes deeper than just the formation of rock and metal. It is a story of survival against all odds. A story of balance so delicate that even the slightest change could have meant a very different outcome. The universe, in its vastness, cared little for the small planet forming in the shadow of its sun. And yet, against the backdrop of cosmic indifference, Earth emerged, scarred by fire, shaped by impact, and destined to become something incredible. Over the next 45 minutes, we will embark on a journey through these billions of years, a journey that will uncover the incredible processes that transform dust into a living, breathing planet. From the fiery beginnings of Earth's molten surface to the cooling of its crust, from the cataclysmic impact that created the moon to the arrival of water and the origins of life, every step is a chapter in the remarkable story of our planet. Welcome to the story of Earth's formation, a tale not just of creation, but of cosmic violence, survival, and the delicate dance of forces that turned stardust into the foundation of everything we know. This is a story unlike any other, a story billions of years in the making, shaped by explosions, collisions, and a relentless drive towards something more. We're about to uncover one of the most extraordinary stories ever told. And it all starts with dust. Stardust, the scattered remains of a star that died long ago. What was left behind after its fiery death may have seemed insignificant, tiny particles adrift in the endless void, but this stardust held the potential to create worlds. It held the potential to create Earth. 4.6 billion years ago, the region of space that would one day become our solar system was nothing more than a vast, swirling cloud of cosmic gas and dust, stretching for light years, drifting silently across the dark expanse of the young universe. This cloud, known as a solar nebula, was massive, filled with the scattered remnants of stars that had lived and died long before. But this nebula was far from calm or motionless. Though it seemed like a quiet void, immense and invisible forces were at work within it. Gravitational waves rippled through the gas and dust, pulling, tugging, distorting the delicate balance of particles in space. These gravitational forces, combined with powerful shock waves from nearby supernovae, explosions of massive stars at the end of their life cycles, caused the nebula to begin collapsing in on itself. What had once been a diffuse, peaceful cloud now started to fold under its own weight, and slowly, this chaos began to organize, to form something entirely new. At the center of this collapsing nebula, something extraordinary was happening. As the gas and dust swirled inward, drawn toward a common center, particles of matter began to collide and merge, compressing tighter and tighter. The pressure at the heart of this growing mass became so immense that it ignited a chain reaction. Hydrogen atoms, the most basic element in the universe, began to fuse together, releasing a blinding amount of energy in the process. This was the birth of a star, our star. The sun had emerged from the heart of the nebula, a fierce, blazing ball of fusion-powered light and heat. It was a moment of creation that would change everything. In that single flash of light, the local universe would never be the same again. But this was only the first stage in a much longer, more complex process that would transform this corner of space into something extraordinary. The birth of the sun did not happen in isolation. The newly ignited star was surrounded by a swirling disk of remaining gas, dust, and debris, the leftovers from the collapse of the nebula. But this debris would not remain as it was for long. Even in the chaotic aftermath of the sun's birth, gravity was still at work. The small particles of dust, rock, and gas within this disk began to bump into each other, sticking together and merging through countless collisions. Tiny grains of dust became pebbles, pebbles became boulders, and boulders became planetesimals, small, primitive building blocks of future planets. These early collisions were violent, with each impact generating enormous heat. These high-energy collisions melted rock and metal, forging larger and larger objects in the process. In time, these growing bodies, under the relentless pull of gravity, became protoplanets, massive enough to start pulling in more material from their surroundings. These were the first stages of the planets we know today. Among these newly forming worlds was Earth, though it was far from the tranquil, life-supporting planet we now call home. In its infancy, Earth was nothing more than a molten mass of rock, a hellish sphere of fire and magma, continuously bombarded by the fragments of debris that still filled the young solar system. The surface of this early Earth was a violent, ever-changing landscape, where oceans of molten lava churned and volcanoes erupted endlessly, filling the air with toxic gases. Every moment of this primordial era was defined by destruction and energy, shaping the young planet through countless impacts. Yet Earth's story was far from over. In fact, one of the most dramatic events in its entire history was about to unfold. At some point in its early life, Earth encountered a rogue planet, a wandering body known as Theia. Theia was roughly the size of Mars, and it was on a collision course with Earth. In the silent, dark reaches of space, this collision was inevitable. When Theia struck, the impact was so violent, so cataclysmic, that it forever altered the course of Earth's evolution. The force of the impact was unimaginable, with energy equivalent to billions of atomic bombs detonating at once. Mountains of molten rock were thrown into space, and a significant portion of Earth's mantle was ejected in a fiery spray of debris. But not all was destruction. From the chaos of this cosmic collision, something new would arise. As the massive fragments of rock and dust were thrown into space, Earth's gravity began to pull them into orbit. Over the next few million years, these fragments slowly coalesced, drawn together by the same gravitational forces that had shaped the solar system. From this debris, a new celestial body was born, our moon. Without the moon, Earth as we know it would be a very different place. It might seem like just a distant, silent companion hanging in the night sky, but the moon's role is far more profound than that. Over billions of years, this celestial partner has acted as Earth's stabilizer, protector, and architect of life's early conditions. One of the most critical functions of the moon is its gravitational influence on Earth's axial tilt. You see, Earth doesn't sit perfectly upright as it orbits the sun. Instead, It's tilted at an angle of about 23.5 degrees. This tilt is what gives us the changing seasons, the shifting balance of sunlight between the northern and southern hemispheres as Earth journeys around the sun. Without the moon, Earth's tilt would be far more unstable. Over long periods, the planet's axis could have wobbled wildly, sometimes tilting steeply and other times barely tilting at all. The consequences of this instability would have been extreme, leading to erratic and extreme climate shifts, devastating ice ages, scorching heat waves, and perhaps even a climate so hostile that life as we know it could never have gained a foothold. But the moon does more than just stabilize the planet's axis. Its gravitational pull also moderates the speed at which Earth rotates. In the distant past, Earth spun much faster than it does today, completing a full rotation in just 6 to 8 hours, compared to the 24 hours we are familiar with. This faster rotation would have created shorter days and far more intense winds, making Earth's environment even more chaotic and unpredictable. The moon's gravitational influence has gradually slowed Earth's spin, lengthening the day to a more manageable pace and helping create the stable rhythms that life depends on. And then there are the tides, the rhythmic rise and fall of the oceans that have shaped our planet's coastlines for billions of years. The moon's gravity pulls on the Earth's oceans, causing them to bulge toward and away from the moon as it orbits around us. These tidal forces do more than just create the gentle lapping of waves on the shore, they have been a driving force in the development of life on Earth. In the early days of our planet, the tides were much stronger, as the moon was closer to Earth. These intense tidal movements would have created vast tidal pools along the coastlines, trapping water and the simple organic molecules that floated within it. These pools provided an ideal environment for life to emerge, shallow, sunlit waters where the concentration of these molecules increased, eventually leading to the formation of the first primitive life forms. Tides also created the crucial mixing of ocean waters, distributing nutrients and regulating temperatures in the world's seas, ensuring that life could flourish once it had taken root. Thus, from the chaos of cosmic collisions, Earth gained not just a moon, but a protector, a partner that has quietly shaped our planet's destiny. The moon's presence is woven into the very fabric of life on Earth, from the predictable cycles of the seasons to the steady, life-nurturing rhythm of the tides. But for Earth to become a living planet, it needed something far more precious than just rock and fire. It needed water, the very essence of life. Without water, Earth would have remained a barren, desolate world. But this life-giving substance wasn't present on Earth in its infancy. When the planet first formed, it was a seething mass of molten rock and metal, and any water that may have existed was quickly vaporized by the intense heat. So where did it come from? Water was delivered to Earth from the farthest reaches of space, carried by comets and ice-filled asteroids that bombarded the planet for millions upon millions of years. These icy bodies, remnants of the early solar system, were hurtling through space at tremendous speeds. As they collided with the young Earth, their frozen interiors released water in the form of vapor and liquid, slowly accumulating over time. Each impact, though violent and destructive, brought with it the precious building blocks for life. Imagine the surface of Earth during this time, a glowing, molten landscape where fire and lava reigned supreme. But with each incoming asteroid, with each icy comet slamming into the surface, droplets of water began to collect. At first, it was a mere trickle, steam rising from the molten ground as the ice melted on contact with the searing heat. But as the bombardment continued over millions of years, the water began to accumulate in vast, low-lying areas of the planet's surface. Slowly, these scattered pools grew larger. They merged, forming vast basins, and as the surface of the Earth cooled, these basins became the first oceans. But these early oceans were not the calm, blue seas we know today. They were chaotic, roiling bodies of water, filled with dissolved metals and toxic chemicals that had been released from the planet's volatile interior. The water, though essential to life, was harsh and unforgiving. It was a soup of primitive elements, churned by the planet's still active volcanic forces. Volcanic eruptions spewed ash, gases, and magma into the air and into the seas, creating a deadly, tumultuous environment. Lightning storms cracked through the thick, toxic atmosphere, while meteors still occasionally rained down from space, sending up massive waves and ejecting clouds of steam and dust into the air. This was Earth's first attempt at becoming a living world. It was wild, violent, and utterly hostile. The atmosphere that hung above these chaotic oceans was a poisonous brew of gases. Methane, carbon dioxide, and ammonia dominated the air, creating a thick, suffocating blanket around the planet. There was no breathable oxygen, no trace of the life-giving air we depend on today. This was an atmosphere that would have killed any modern life form in an instant. Amid the chaos and violence of early Earth, in the murky depths of the oceans and shallow waters, life was quietly undergoing a revolutionary transformation. The first living organisms, tiny and simple as they were about to reshape the entire planet. These organisms were cyanobacteria, ancient microorganisms, so small they were invisible to the naked eye. Yet these minuscule beings were the true architects of Earth's future. In a world dominated by toxic gases, cyanobacteria were among the first organisms capable of a groundbreaking innovation, photosynthesis. This process, which harnessed the sun's energy, was nothing short of revolutionary. While earlier forms of life had relied on the Earth's internal energy and chemical reactions to survive, cyanobacteria turned their gaze toward the sky, capturing sunlight and using it to convert carbon dioxide, which was abundant in the atmosphere, into organic compounds that fueled their growth. But there was another, even more important byproduct of this process: oxygen. In the beginning, oxygen was little more than a waste product, released by cyanobacteria as they metabolized carbon dioxide. To them, oxygen was insignificant, a simple byproduct of their quest for energy. But what these organisms couldn't have known was that the oxygen they were releasing would change the very nature of the planet. Slowly but steadily, over hundreds of millions of years, the oxygen produced by cyanobacteria began to accumulate in the atmosphere. At first, this oxygen was absorbed by the vast oceans, reacting with dissolved iron and other elements to form rust-like iron oxides that sank to the ocean floor, creating what we now call banded iron formations. For millions of years, the oceans acted as an oxygen sink, capturing and storing the newly produced gas. But eventually, the oceans became saturated with oxygen, and it began to seep into the atmosphere. At first, the impact was minimal, an invisible trickle of gas entering the sky. But as the cyanobacteria continued their relentless work, day after day, year after year, the concentration of oxygen in the atmosphere began to rise. It was a slow and steady process, so gradual that if you were there to witness it, you wouldn't notice any changes within your lifetime. Yet, over the course of hundreds of millions of years, these small organisms began to alter the very air of the planet. This transformation wasn't instantaneous, and it wasn't without consequence. In fact, the rise of oxygen in Earth's atmosphere triggered a planet-wide extinction event. Oxygen, which is essential for modern life, was toxic to many of the anaerobic organisms that had thrived in Earth's oxygen-free environment. As oxygen levels increased, these early life forms faced an existential crisis. They were either forced to retreat into oxygen-deprived environments or driven to extinction. This event, known as the Great Oxidation Event, was one of the first mass extinctions in Earth's history. But out of this catastrophe, new possibilities arose. Oxygen, though deadly to some, became the foundation of life for others. Over millions of years, new forms of life evolved that were able to not only tolerate oxygen but use it as the basis for more efficient metabolic processes. This paved the way for more complex organisms, multicellular life, that could thrive in this new oxygen-rich world. As oxygen levels continued to rise, Earth itself began to change. The oxygen in the atmosphere reacted with methane, a potent greenhouse gas that had helped to warm the early Earth, leading to a significant cooling of the planet. The once hot, inhospitable climate began to stabilize, and Earth entered one of its first ice ages. This cooling period, though challenging, set the stage for even more dramatic changes in the planet's climate and geography. The atmosphere was now beginning to resemble something closer to the one we breathe today. For the first time in Earth's history, the sky turned blue, as oxygen reacted with ultraviolet radiation from the sun to form the ozone layer. This thin, protective shield of ozone was vital. It blocked harmful radiation from reaching the surface, creating conditions that would allow life to move from the oceans to the land. Without the ozone layer, life on Earth would have remained confined to the deep oceans, forever vulnerable to the harsh, sterilizing rays of the sun. Meanwhile, in the oceans, cyanobacteria continued to thrive. Their influence spread far beyond the atmosphere. The oxygen they released created new ecological niches, and marine life exploded in diversity. Simple organisms gave rise to more complex ecosystems, and early forms of algae and other photosynthetic organisms emerged, further increasing the production of oxygen. But this wasn't just an atmospheric transformation, it was a planetary one. The oxygen-rich atmosphere allowed Earth to cool and become more geologically active. With less greenhouse gas trapping heat, tectonic activity intensified, and the planet's crust began to fracture, creating vast mountain ranges and deep ocean basins. Earth was slowly sculpting the landscapes that would eventually become home to even more diverse and complex life forms. It's hard to overstate the impact that cyanobacteria had on our planet. Without them, the atmosphere would have remained suffocating, unbreathable by modern standards. The skies would have remained thick with methane and carbon dioxide, and the Earth, hostile to anything but the most primitive forms of life. But with each molecule of oxygen that these tiny organisms released, they were laying the groundwork for a future they could never have imagined. Massive tectonic plates, colossal pieces of Earth's crust, began to shift and move. This slow but powerful movement was driven by the heat trapped in the planet's interior, a force that had been building since Earth's formation. The surface of Earth was no longer a singular, solid shell. Instead, it was divided into these gigantic plates, which floated atop a layer of semi-molten rock in the mantle below. These tectonic plates were anything but static. They collided, they pulled apart, and they slid past each other in a process that has never ceased, one that continues to this day. It was this relentless, unstoppable movement that began to raise new continents from the depths of the primordial oceans. Massive landmasses that had once been submerged beneath ancient seas were slowly pushed upwards, breaking through the surface of the waters. Earth was reshaping itself, creating the very landscapes we know today, the continents that would become home to the rich diversity of life. These landmasses were anything but stable. The tectonic plates continued their slow but powerful dance, forcing the continents to drift across the globe over millions of years in a process known as continental drift. At times, continents collided, forming towering mountain ranges that pierced the skies. Other times, they were torn apart, creating vast ocean basins and rift valleys. This constant motion, though slow by human standards, was the driving force behind Earth's ever-changing geography. On these new continents, life found new territories to explore. Primitive plants, having evolved in the oceans, were the first to colonize the land. Mosses, ferns, and other simple plants crept onto the shores, transforming the barren landscapes into verdant green oases. This was the beginning of an evolutionary explosion, as life adapted to the harsh and varied environments that the continents provided. As plants spread across the land, they created new habitats and ecosystems, paving the way for more complex life forms to follow. The oceans, once the sole cradle of life, were no longer the only place where life could thrive. Soon, primitive animals began to emerge from the waters, taking their first tentative steps onto land. These early amphibians, small and simple, were the pioneers of a new world. They explored the vast, untamed wilderness of the continents, adapting to life outside the water. With each generation, life on land grew more complex and diversified. Over millions of years, evolution continued its relentless march forward. Reptiles, birds, and mammals appeared, each more advanced than the last. The continents themselves continued to shift and reshape, breaking apart and coming together in new configurations. Mountain ranges rose and eroded, deserts formed, and forests flourished. Life adapted to each new change, thriving in the new environments that tectonic movement created. And then, in a relatively recent chapter of Earth's history, humans appeared. We, the descendants of primates that had evolved in the rich ecosystems of Earth's forests, found our place on this planet. We were shaped by the same forces that had sculpted the land, the same processes that had lifted continents from the oceans and built mountains from the depths of the earth. We are the product of billions of years of change, adaptation, and evolution. Our ancestors adapted to the environments they found themselves in, and as they did, they developed the tools, intelligence, and resilience that allowed them to thrive. From those early hominids, who roamed the African savannas, to the advanced civilizations that built cities and explored the stars, humans are a testament to Earth's incredible evolutionary journey. Today, we live on a planet that is constantly in motion. The tectonic plates beneath our feet are still shifting, still creating mountains, valleys, and new ocean basins. Earth's climate continues to evolve, shaped by both natural processes and, increasingly, by human activity. The story of Earth is not a finished one. It is still being written, every single day. In fact, we are now an integral part of this story. Our actions, our industries, our consumption of resources, our technology, and our environmental choices, are directly influencing the planet. We have become a force of nature in our own right, capable of shaping the environment in ways that were once reserved for geological processes alone. Our cities rise where mountains once stood, our roads carve through forests, and our pollution changes the very composition of the atmosphere. We are, in essence, co-authors of Earth's future. Every day, we are writing the next chapter in Earth's history. What will that chapter be? Will it be one of restoration and preservation, where humanity learns to live in harmony with the planet that gave us life? Or will it be a chapter of struggle, where our impact on the environment leads to unforeseen consequences, changing climates, rising seas, and lost ecosystems? The future is impossible to predict with certainty, but one thing is clear: Earth's story is far from over, and our role in that story is just beginning. As we look ahead, we must remember where we came from. Earth is a world born from fire, shaped by impacts, and transformed by life itself. It is a planet that has survived the most violent forces the universe could throw at it, and yet it has nurtured the delicate spark of life. Every collision, every volcanic eruption, every shifting tectonic plate, and every particle of stardust has contributed to the creation of this fragile, beautiful world we call home. It is miraculous to think about how each step of Earth's long journey, from the fiery birth of the solar system to the formation of the oceans, from the rise of the continents to the evolution of life, has led to this moment. Earth is not just a rock hurtling through space. It is a living, breathing system, a world of incredible complexity and beauty. And we, as humans, are part of that story. We live on a planet that has seen billions of years of transformation, and its ability to adapt and evolve is awe-inspiring. But now, more than ever, the future of this world depends on the choices we make. We are the guardians of this extraordinary planet, and as we move forward into the unknown, we must tread carefully, with respect for the forces that created the landscapes, climates, and ecosystems that sustain us. What will our legacy be? Only time will tell.